Hello everyone, and welcome back to my C++ programming tutorial series. Second video today here, and my name is Joe. Welcome back, and today we're going to take a look at another just introductory program in C++, talk about some new things, but in general this video is going to be much shorter than the last one as we have a lot of the introductory content behind us, so we're going to be able to jump into this new code quite a bit quicker. I made a few changes to Visual Studio 2013, so you'll be able to see those in just a minute, and I'm going to show you how you guys can adjust those settings as well. So first off, we're going to create a new project. And again, we're going to do a Win32 console application. Again, this is under the Visual C++ template, and we want to make sure that it's still in our proper directory. Again, I'm using C++ directory in my documents directory personally, but you can store yours wherever you'd like. This one we're going to call example2.2. Again, I'm referencing the second chapter of the C++ primer book by Stephen Prata, published by Sam's Publishing, as a reference. You don't necessarily need to have it to follow the series, but I do recommend picking it up just to support them because it's a great book, and it's a great book. Good one to have if you want to get serious about programming in C++. So we got all that. We're going to hit OK. We're going to go next, and again, you want to remember to select empty project so that we don't have all that extra garbage that we don't need right now thrown in there. So empty project, we're going to go ahead and hit finish. And there we go. We got our solution over to the right. One thing I want to mention, if you don't want to create a project for every example, you could go ahead and just make like one project per kind of section, and then just add the source files in independently, and like you could have all of the source files from this first section of the tutorial series all in one project, and just have a bunch of source files. Just for my preference, I'm going to create a project for every example, even though it's not really necessarily necessary. It's kind of overkill, but I'm going to do it anyway. So again, we need to add a source file so you can actually add some code here. So we're going to want to right click, go to add, go to new item. Under Visual C++, we're going to select the C++ file, and we're going to call this one carrots.c++. We're going to add that in here. And I'm trying to think, okay. Let me actually type this in before I explain the changes that I made to Visual Studio here. So I'm going to enter in our program here, and then we'll go over the changes that I made to Visual Studio for the purposes of this tutorial series, and then we'll go into what the program is and what's new that we haven't seen before in the previous video. So here we go. Get a comment. This is going to be carrots.c++. And this is going to be a food processing program. It's going to use and display variables. Alright, so we're going to include our IO stream. We're going to make our main function. And we're going to put some code in there. Do our using namespace std again, in carrots equals 25, and we have some more cout content again, just like the last one. And that. Change this up a bit here. Carrots -1 and some more display. Crunch, crunch. Now I have turn 0, and I'm gonna add in my own little bit of code here. Ugh, forgot to put my hair up in a ponytail, so it's all in my face. Alright, so here we go. We got our code. Now, if you watched the previous video, let me get this output shrunk down a little bit because we don't need it that large. We can also move over our Solution Explorer too. You may notice that the couple things are different. The obvious one is going to be that the text is a little bit larger in this video. Also, this one may not be as obvious, but I'm using a different font in this video as well. And also, off to the left, we see we have our line numbers displaying. So each line has its own number. This is basically just makes it much easier to debug whenever you get an error in your code. So how do you do that? If you want to change any of this stuff on your own, we'll show that real quick. You're going to want to select Tools, and you're going to want to go to Options. And it's kind of not really obvious. Hopefully I can actually remember where everything was. But the first one you're going to want to select, if you want to modify the text at all, is going to be an environment. And first, under General, one thing that I recommend doing is playing around with these color theme settings. Basically, it just sets the theme of the program itself. So I'm going to be using the blue default color theme, but there is also a dark theme. So if we switch to that, we can see that we have a darker background and lighter text. I kind of like this when I'm actually programming on my own, but for video purposes, it's I don't think it's quite as easy to see. You also have light, which is very similar to the blue, but instead of having any blue, it's just all light colors. So we're going to switch back to the blue. Switch that. The next thing is, if you come down here again under Environment, if you go to Fonts, Fonts and Colors, you have a few options, and you can change these font options for a lot of different areas of Visual Basic, but the default text editor is really all that I changed, and all you'll need to change. So, first off, you're going to be able to choose your font. I actually forget what the default font is, but I like Courier or Courier New. They're pretty much the same, but it's just a nice monospace font, which monospace basically means that no matter what the character is, it's going to take up an equal amount of width, and that makes coding and readability a little bit easier for me. Then you have your font size, so I bumped that up from, I think it was 10 or 11 up to 13, so that's a little more visible. And you can also go in and choose, actually, I don't know if that did anything. Interesting. You can change your background and your foreground for your text editor as well from here. The next one is, see if I can remember. Okay, here it is. Oops. So if you come here under Text Editor, select that and choose C++. There's this little option here called Line Numbers. You want to check that box and hit OK. Even if you don't end up changing the font size or the color theme or anything, I definitely recommend putting on line numbers because it makes it much easier. Okay, so that covers the differences between the changes that I've made. So next we're actually going to go into the code itself. So first line here, we have our include that we went over the last time. So we're including this header file IOStream, and I didn't really go into what IOStream is, what IOStream contains, but it's basically an input-output header file that allows us to use input and output commands like cout, and we'll be using plenty of other commands from the IOStream header file later. We have our main function, which again is required for our program to function. It tells our computer and compiler, this is what code I want you to execute. Anything with this main. If that doesn't exist, the program's not going to work. And then we have our namespace, so we're using the std namespace so that we can type cout instead of std : cout. Again, that'll be explained when we talk about namespaces more, which won't be for a while. And then we have some new things. We've seen int before. That's up here. We talked about what integers are. They're basically whole numbers. They can be negative numbers, they can be positive numbers. And then we have this word carrots. And, well, that doesn't seem like that would be a command. Well, let me put some comments in here. Get them out of ways. So, in this line, we are declaring an integer variable. Now, what does that mean? Well, there's a couple types of statements in C++. This particular statement, so this line of code called a statement, is declaring a variable. So it's basically telling our compiler, I want you to reserve some memory and assign it to this variable that that I'm defining in this declarative statement. So basically what this line means is I want the compiler to reserve a section of memory for me to make an integer, to hold an integer, and I want to call that variable carrots. So you can call it whatever you want. I could call it jelly belly. You know, I could call it whatever, but I'm calling it carrots because this program is about carrots and how great they are. So yeah, we're declaring a variable here, an integer variable. Whenever you declare a variable, you do have to specify before the name of the variable. You have to specify what kind of variable is it. Is it an integer? Is it a float, which is a decimal value? Is it a boolean, which would be true or false, or 1 or 0? Is it a string, which would be, you know, what we have in quotations here is a string. It's a string of characters. And there's a bunch of different types of variables that we can define, and it's important to tell the computer what kind of variable it is, because that influences how much memory the computer is going to reserve for that variable. Now, C++ int, let's take a look here at C++. I don't know if it's going to tell me int. Alright. So it looks like, and this, I might not be reading this correctly, but it's basically reserving us 16 bits of space in memory for this variable. And no matter what we do to this variable, if we change it, if we assign it a value, it's going to be located in that same spot in memory all the time unless we tell it to go somewhere else. So basically here we're making a variable. The variable is called carrots. Right now it doesn't have it. There's no value associated with it because we haven't given it one. So yeah, and actually there is a value associated with this. It's whatever like random garbage is in that memory location at this point. So if you just declare it and then you don't assign something to it, if it doesn't give you an error and it actually displays something, it's going to be a bunch of garbage, or some just random number. So there we go. We got a declarative statement. We created a variable, and variables are key to programming. Without variables, you really couldn't do very much with a program. So now down here on this line, we assign a value to the variable. So we have our declarative statement, and then we have our assignment statement down here. So two different kinds of statements. This one is declaring or creating a variable, and this one is assigning a value to it. The syntax of this line here, this assignment, is important. As you can see, we have the variable name over on the left side of our equal sign, and then we have our value that we're assigning it over on the right side. So to assign a value to a variable, you do that with the equals operator, and basically that is telling the compiler carrots is equal to 25 now. So we're assigning 25 to carrots. If I put 25 over on this side, that's not going to work. It's going to give me an error. So you always have your integer value over on the left side, or your integer, your variable over on the left side, and your value that you're assigning to it on the right side. So that's very important, and that's just what you have to do. So down here, add another comment in. Display the value of the variable. So we have a familiar command. We have our cout, which we remember displays something to our console. And again, whatever is over here on the right side is being passed to that command, which is being displayed on our console. So we're passing the string, we're passing these words, these letters, I have to cout, and then that's displaying it on the console for us. Now, down here we're doing something that we haven't done before. In the last program, everything that we did with cout, we were always passing it strings. It was always displaying strings. This one, it's not within quotations, so it's not a string. So what's it doing? Well, so we created this variable called carrots up here. We assigned it a value, and that value that we assigned to it is 25, which is an integer. So that's good. And then down here, we are passing the variable carrots to cout, which will then output carrots. So is it going to actually say, when it outputs, is it actually going to output the word carrots? No, it's going to output whatever the assigned value of this variable is. So what assigned value do we have for carrots? Well, we just assigned it 25 up here. So when we execute this command cout carrots, it's actually going to display 25 because that's what we've assigned carrots to be. So if you remember from the last video when I was talking about how cout works and how it leaves the cursor wherever you tell it to leave it, we can see that with these two commands we know that it's going to print out I have, and then it's going to print out a space because I put a space here, and then we come down here, it's going to print out the value of carrots, which is 25, right after that space because we didn't tell it to give us a new line yet, and that cursor is going to be left right after this. And then we come down here and we're telling it to print out space and then carrots, period, quotation, and then down here we have end line, end L, which is going to put in an extra line for us after these three commands have completed. So we can imagine that when we run this program up to this point, it is going to say I have space 25 space carrots, period. And then it's going to enter a new line, and we'll be on a new line. So let's actually do that. And I'm going to do something here. So I'm going to run it. Oh, I'm a fool. Yes, that's very nice. And remember, get car basically just stops the program until I hit the enter key. Okay, so I'm just running up until this line here, and I'll explain why that is in a second. And as we see, it displayed exactly like we have. It came through, it displayed I have space. Yep. Carrots, which we assigned 25, and it's showing 25. And the space carrots, and yep, we're getting space carrots. And then we are getting an end line, so it moves the cursor down here. Everything works just like we expected it, and it's waiting for me to hit that. Now we're going to build debug, stop debugging. Okay, so how did I get it to just stop where I want it to? Well, basically, if over to the left of the line numbers, and we'll talk about this more when we actually have to use it, but I might be using it for some demonstration purposes here. Basically, if you click over to the left of the line number, when you hit the play button up here and start debugging or executing the program, it's basically going to run through all of the code until it hits this red circle, which is called a breakpoint. So since I put the breakpoint on line 18, it is going to execute everything up until line 18. It's not going to execute line 18 yet. And this is very powerful for debugging, so we'll be using it a lot more in the future. Okay, so we got this whole section of our program figured out. Now down here, we are going to modify the variable. Put a semicolon. We don't need that because that's a comment. And remember, comments denoted by the 2 forward slashes are just notes for us. The program itself is not going to execute any of this. It's going to ignore it completely. So down here, what do we have? Well, we have a statement that's going to be modifying the value of carrots, modifying our variable. So when we take a look at the statement, we see, just like up above here, this is an assignment statement, just like this one. Even though we're modifying the value, we're still assigning a value. So we have our variable name over to the left, just like we did above here. Again, that is required. You have to have your variable name or your variable over to the left of the operator. And then we have equals, so that means we are assigning it whatever value falls over to the right of the equal sign. And over here, we are saying whatever number is in carrots right now, subtract 1 from it. So when you're doing C++ and a lot of other programming languages, the math operators work just like you would imagine. So minus is going to minus, plus sign is going to add, an asterisk is going to multiply, a forward slash is going to divide, so on, and then we have some other options that we'll be using for more advanced modifications, like if you wanted to square root, for example. There's a way to do that. So basically what we're doing here is we're telling carrots that we are assigning it a new value, and the value that we're assigning carrots is carrots minus 1. And since we already assigned carrots 25, this value here is actually going to be the current value of carrots, so it's going to be 25 minus 1, so we're going to end up, if everything works right, we're going to get 24. So we're assigning carrots a new value of itself minus 1, which is 24. And then after that, we're going to print out one more line. We're going to print out crunch, 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 or crunch, crunch. Now I have, and then space, and then we're going to display the current value of carrots, which should be 24, since we just subtracted 1 from what it was before. And then we're going to pass it space carrots, and then an end line right after that. And remember, in the last video we talked about up here we have, one basically display per line, but you can string together multiple things that you want this to print out just by kind of stringing them together with the less than operator, which just keeps passing things to cout, and it'll operate. It'll display exactly as you have it laid out here. Now, since this here is a string, it's a different data type as carrots, because our carrots is an integer. It's an int. So I wouldn't be able to just say now I have carrots, because it's just going to display now I have carrots. To let the program know that you want it to display the value of the variable carrots instead of the word carrots, you have to pass in that variable afterwards with no quotation marks around it. That way it knows it's not the text carrots, it's the variable carrots. And you also have to, each time you add something new to your output, you do have to have this operator, the less than. We wouldn't be able to, for example, say I have carrots end L, because if we hover over this, we have an error. So you do have to have that operator in between each. Oh, I messed that up. I put it in the string. In between each thing that you want to output. And then, so yeah, we have the end line, which again, instead of that, you can do the \n, which is our new line character, if you want to save some space. Finally, we have getChar, which again just pauses the program and waits for us to hit enter before it continues. And then finally we have return 0, which is going to tell our compiler this program is done, return the value 0, and then the program will be done. Whew. So we're about ready to run this. Let's go ahead and do it. Since I've made changes since the last time I ran it, I'm going to need to build it again. Hit yes. And, oh, 1 minute. I forgot I snuck this extra getChar in there for demonstration. So basically what that was doing, since I had getChar down here, is it was displaying these 4 lines, and then it was waiting for me to hit enter, and then it was displaying the next line. So we'll get rid of that. Okay. So we see here that we get the output. I have 25 carrots. Crunch, crunch. Now I have 24 carrots. It worked just like we expected. And one thing off topic, man, when you look at the word carrots, it really just, that is such a weird, it's a weird word. It's like carrots. It's, I don't know. I keep looking at it and it just seems weirder every time. Anyway, so again we're making an integer carrots. We're assigning it the value 25. We're printing out I have space, followed by the value of carrots, which is 25. Then followed by space carrots. And then we have an end line. So we have all that displayed here, and then it kicked a new line in. And then we're subtracting 1 from the current value of carrots. So that is now making carrots equal to 24, since it's 25 minus 1. And then we're displaying crunch crunch. Now I have the value of carrots, and another end of line. And that's exactly what we see here. Now I have 24 carrots. And then we're waiting for space. And then after I hit that space, everything returns and we're done. So, hopefully that is understandable. If any of that's confusing, feel free to tell me in the comments. This is my first time trying to explain programming, or really anything, to anyone, so I may not be doing the greatest job right off the bat, but hopefully it is clear enough for the purposes of this video. Again, things are going to be covered in more detail and repeated as we go on. So that is that. There were a couple things that I wanted to talk about. Let me make sure I didn't miss anything super important. I did want to mention one thing, which I don't know if it's a great idea to do at this point or not, but we'll do it anyway. There is a way to basically have your declaration and your assignment on the same line. So for example, we can declare the variable carrots, and we can assign it the value of 25 all at the same time. If we were going to do that, and I'll just do it down below for an example, obviously this won't affect our program, or it won't work because we're outside of our main function. But if I wanted to declare and assign a value to a variable all in one line to save some space, what I'd be able to do is type in int carrots and then simply equals 25. And basically that creates and assigns a value to the variable all in one line. For best practice, it is generally better to declare your variable on a separate line. And the reason for this is a lot of programmers prefer to declare all of their variables in one area so they can kind of quickly glance at all the variables within a function or an object. So it's best to do that. So for example, if I wanted to make carrots, I wanted to make beets, and I wanted to make plums, it would be best to do beets, plums, to assign each, or declare each one and then assign them values. So, oops. Alright, so then I'd go beets equals 2, because I don't like beets as much as carrots, so I don't want as many of them, and plums equals 700, because I really like plums. So that would kind of be, that's the preferable way to do it. However, it's a lot quicker to just declare and assign it all in the same line. So we'll be using both methods as we go through this tutorial series. Okay. The other thing that I was going to mention, and this may be getting a little bit advanced, but if I don't mention it now, I may forget to mention it later. Another thing that we can do is if I declare 3 variables, let me actually just do what I had before. Int beets, int plums. So I declare 3 of these and say I want 25 of all of them. I just want them all to be the same amount, at least for now. I can change the value of each one independently later, but I just want them all to be 25 to begin with. Now I could go through and I could go beets equals 25 and plums equals 25. Or I could be more efficient or more lazy, depending on how you look at it, and I could do something like this. So in the same line as carrots, I could do this. I could go carrots equals beets equals plums. Now, in this situation, if I'm not mistaken, and I'm actually going to have to double check on this real quick, but I believe how this works is it's going to process from the right to the left. So it's going to assign, well, let me make sure that's correct before I lead you astray. Maybe. Yes. Okay, perfect. I was correct. So it does work from right to left. So first off, how this one line of code is gonna work is it's gonna assign 25 to plums, and then it's gonna assign the value of plums to beets, and it's gonna assign the value of beets to carrots. So basically, it's gonna assign 25 to this. This is 25, so it's gonna assign it to this, and this is 25 now, so it's gonna assign it to this. Therefore, everything's 25. Yeah, you won't see a lot of this. There's better ways if we need to assign the same variable to multiple things, in my opinion. So this isn't something that we're really going to see very often. Get rid of all that. But I just wanted to point it out before I forget to mention that is another way that you can assign a value to some variables. Okay, one more thing I wanted to cover. And that is, I never mentioned this in the previous video, and it is extremely important, and that is everything is case sensitive. When you're programming, you are gonna, and if you're following along with me, you're gonna want to follow along with exactly the same case, whether it be upper or lower case. Make sure that that is it's the same. The reason for that is if I were to change this to capital C O-U-T and I try to run that, there's an error. What error do we get? We have on line 13, which now that we can see our lines, we see that it's 13. We have cout is an undeclared identifier. What? That's not right. Cout, we used cout before. Well, that's because cout with a capital C is different than cout with a lowercase c. Same as it's different than all uppercase or lowercase, uppercase, lowercase, uppercase. Basically, if you're using a function or an object or a command, it has to be the exact same case as it needs to be. So most things are going to be lowercase. Now, one thing that is a little bit different is like carrots. If I change this to a capital C, and I changed all the other instances of carrots to a capital C, that wouldn't matter. You can call your variables whatever you want. I could call it C, lowercase a, uppercase R, lowercase, or I could even do 0. Actually, yeah, 0 T Z. I can spell it like that, as long as I call it the same thing every time I reference it. So I change this to that, and this to that, and this to that, and this to that, and this to that. It'd be fine. You can call your variables whatever you want, but you have to call them the same thing every time, and you have to use the same case. Same with int. If I do uppercase I, nope, doesn't see that as a proper data type. So case sensitive. Everything's case sensitive. Follow the case as I type it. Again, pretty much all like commands are gonna be lowercase, or they're at least gonna start out lowercase. Now, some commands may have uppercase characters in them, and the reason for that is most programmers follow what is called the Camel code naming convention, and what that is everything starts with lowercase. So if it's one word, we have carrots, It's all lowercase. The first letter is going to be lowercase. Even if we were using a proper name, like my name Joe, I'd still do lowercase. Now, if my variable, if I wanted it to be called lots of carrots, so that's all lowercase, but it's kind of hard to read because it's all lowercase, so you can't differentiate, which is a different word. So instead, what I would do is the first word would be lowercase, and then the first character of the second word would be uppercase, and the rest would be lowercase. And from then on out, the same rule would apply for all other words. So we'd have lots of with a capital O, and then carrots with a capital C, all the rest lowercase. So that is what camel case, the camel case naming convention is, and I highly recommend that you use it because it's easy to read, it's compact. Instead of, for example, an alternative would be putting underscores under everything, and that just makes it really, and it's hard to see. Let's see. Put it up here so it quits underlining it. Well, it's still going to underline it because I haven't assigned this anything, or I haven't declared it. So, I mean, those are two ways to do it. I recommend camel case. Again, you have your first letter, or your first word, all lowercase, and then every word following that, the first letter is going to be capitalized. So lots, capital O-F, capital C-A-R-R-O-T-S. Lots of carrots. Easy to read, and that's the way it should do it. Now, you may be wondering, why not just do it like this? Well, remember in the last episode how I talked about white space not mattering except in certain situations? Well, this is one of those situations. This would be 3 separate variables, and if I did int caret lots space of space carrots, it's not gonna declare lots of and carrots. It's gonna give me an error. Actually, let me run it. Line 10. Yep. So, it's going to give you an error because you can't have spaces in the middle of your variable name. So use camel case. It's the best naming convention, and that's what we'll be using throughout this series. And I think that's about going to cover it. I'm going to run this one more time, make sure I have everything correct here, go through it again. So once again, we're including our IO stream header file so that we can use our output function, which is cout. So the I stands for input, the O stands for output. If we didn't have this, we'd get an error that this is an unrecognized value or command. Then we have our main function. We are using the namespace std. Again, don't worry about that. Just know that you should use it for now so that we can use cout without typing some stuff in before it. We are declaring a variable carrots. We are assigning that variable carrots the value of 25 as it is an integer. We are then printing out I have 25 carrots. End line. We're subtracting 1 from that. So now our value of carrots is 24, and we're printing out crunch crunch. Now I have 24 carrots. And another end line, we're waiting for an enter, and we're returning 0. And as we can see down here, we exit with a code of 0, which means all our code worked without any major issues. So that is going to cover it for today's lesson. Next time, I think we have a few more examples in this section here. Yeah, it looks like at least a couple more, maybe 3, 4, 2, 3, 4, 5, 6. Yeah, 4 more examples in this section, and then we'll be moving on to the next one. after we're done with this section, we're going to go over a bunch of examples, and I might end up doing that in a live stream that I record so people can kind of, it can be a collaborative process of doing the examples together. But if you enjoyed this, again, I do definitely appreciate a like, a subscribe, if you're enjoying it, you know. And if you have any questions or comments, definitely feel free to leave them in the comments section, and I'll be taking a look and answering any questions and taking in any feedback. So, thanks for watching. My name's Joe, also known as Hoodie Mage here on YouTube, and even though I doubt that anyone that this applies to is watching right now, this channel was primarily a gaming channel to start out with. I will be doing some more gaming videos in the future, so if that's the kind of stuff you're looking for, stay tuned, and that is going to be coming soon once I get some video editing software that I'm happy with. Alright, well, we covered a decent amount here today, and I'll see you guys in the next episode. Thanks for watching.